Hi, in this lesson, I'm going to show you how to approximate square roots to the nearest whole number. And to do that, I have kind of three steps here. The first thing is I'm going to look at a number like 54, and I want to look at which two perfect squares is the number 54 between. So I like to just write down my 54, and then I got to think about perfect squares that are close to 54. Well, I think back to our lesson on perfect squares, and 49 is a perfect square. That's close to 54. Let me write that down. So I have 49. That would be smaller than 54. But then my next perfect square was 64. Well, that would be bigger than 54. So I look at that and go, 54 is between the perfect squares of 49 and 64, which then leads me to my next question. The square root of 54 is between which two consecutive whole numbers? In other words, when I take the square root of these numbers now, so if I take all this and bring it down, and now take the square root of them all, right? Let's go with blue. So I'm taking the square root. So now you can see, here's that square root of 54. Well, I don't know what the square root of 54 is because I don't know that one number that multiplied together is 54. But I do know the square root of 49 is 7, and I do know the square root of 64 is 8. Therefore, the square root of 54 is somewhere between 7 and 8. Now the question is where, or which one is it closest to? Now, to tell whether the square root of 54 is closest to 7 or if it's closest to 8, I just come back here and I go, well, is 54 closer to 49 or is 54 closer to 64? Well, 54 is only 5 away from 49, but it's 10 away from 64. Therefore, the square root of 54 is going to be closest to 7. So if I had to approximate the square root of 54 to the nearest whole number, 7 would be my answer. I have another one here, same thing, just I used a different number. Now it's 96. So the first thing I want to look at is go, what two perfect squares is 96 in between? Well, I have my 96. I got to think of a perfect square that's just less than 96, or the one that's next. And that would be 81. And the perfect square on the other side, the bigger one, would be 100. So 96 is in between the perfect squares of 81 and 100. Now, I want to take a look at the square root of 96. That's between which two whole numbers? Well, that again, I'm going to take what I did earlier, and now I'm just going to take the square root of everything. Because now you see the square root of 96. Well, that's between the square root of 81, and the square root of 81 is 9, and the square root of 100 is 10. Therefore, the square root of 96 is somewhere between 9 and 10. Now, if I had to approximate it again, in other words, the square root of 96 is closest to which whole number? Well, now I just go back up here and I go, well, is 96 closer to 81 or is 96 closer to 100? 96 is only 4 away from 100. It's closer to 100. Therefore, the square root of 96 is closest to 10. In other words, another way to ask that same question is, what's the square root of 96 rounded to the nearest whole number? 10. Same thing. Now I'm going to use the number 22.5. So which two numbers, or which two perfect squares is 22.5 closest to? Well, I have my 22.5. Perfect square smaller than 22.5 would be 16, and the perfect square larger than 22.5 would be 25. So let's take these, let's bring them down, because that's going to help us answer this next question of, well, the square root of 22.5 is between which two consecutive whole numbers? So let's take the square root of all of them, and now we have, well, square root of 16 is 4. Square root of 25 is 5. Therefore, I know the square root of 22.5 is somewhere in between 4 and 5. And if I had to round it to the nearest whole number, well, we just have to figure out, is 22.5 closest to 16 or 25? Well, it's only 2.5 away from 25. Therefore, the square root of 22.5 rounded to the nearest whole number would be 5. Now, my next one, we're going to take a look at solving equations again. And these equations have squared variables in them. So remember, when we want to solve an equation that has a squared variable, we have to, I like to think of as undo that square. And to undo a square, remember, take the square root. So when I take the square root of t squared, we get t. But now, if I take the square root of 78, that was what we just got done doing in the previous example. I look at 78 and go, that's between which two perfect squares? Well, it would be between, let's use purple. 64, we have our 78, and then we have, the next one would be 81. Well, if we took the square root of them, this would be 8. Take the square root of 81, that's 9. Which one is it closest to? Well, 78 is 14 away from 64, and 78 is only 3 away from 9. So then what I would do down here is I would say, I'm going to go with 9. Now, I have a typo here because I didn't want to round this to the nearest tenth. I wanted to round it just to the nearest whole number. So let's change that. I apologize for my typo there. To the nearest whole number. Abbreviate that. There we go. Okay? So it's going to be t will equal 9. Now remember, when you take a square in the equation, we can't just look at the positive solution. We also have to look at the negative solution. So when I take and find a solution to t squared equal to 78, my final answer is right here. And t is either going to equal positive 9 or negative 9. Now let's come over here to the 15 equals x squared. We're going to do the same thing. We're going to take the square root of both sides because that's going to get us to x on the right side equals, and now we have to figure out this square root of 15. So again, I'm going to do the same thing. 15, perfect square that's smaller than 15, that'd be 9. And the perfect square bigger than 15, that would be 16. And if we take the square root of all of these now, I can see the square root of 15 is what I want. The square root of 9, remember, was 3. The square root of 16 is 4. And if I'm going to round my answer to the nearest whole number, I just have to figure out, well, is 15 closer to 9 or 16? Definitely closer to 16, so I'm going to go with 4. So x is going to equal 4, but remember, in an equation we have to look at the positive and the negative, because either one could be a solution to our equation. And we've solved that equation as well by taking the square root of both sides of your equation. And the last type of examples that I have would be to put our numbers in order from smallest to biggest, or from least to greatest, as this is saying. Now I think you're going to have no problem with 3 of these numbers, the 9, the 7.5, and the 7. Those are pretty straightforward as far as putting them in order from smallest to greatest. So I'm just going to start with those numbers, and I'm going to go 7 is going to be my smallest. We know that. 7.5 is next, and then 9. Now the question is, where's that square root of 63 going to go, and where's the square root of 51 going to go? So to do that, I'm going to look at the square root of 63 and do the same thing that I did in all the previous ones and go, well, which two perfect squares is 63 in between? Well, we'd have 49 this way, and we'd have 64 this way. And then if I take the square root of both of them so that I get it closest, I'm going to look at, this is going to be 7, and this is 8. Now, is 63 closer to 64 or to 49? Well, it's closer to the 64, therefore the square root of 63 is closer to 8. Well, I know it's somewhere in between 7 and 8, closer to 8, so therefore it must be larger than 7.5. But obviously it's not bigger than 9, so my square root of 63 is going to slide right in there. It's somewhere in between the 7.5 and the 9. And then I have to do that same kind of thing with the 51. Well, the smaller square root would be 49. The larger one is 64. Take the square root of my perfect squares. This is 7. This is 8 again. So, but this time notice the 51 is much closer to the 49 Therefore, the square root of 51 is going to be closer to 7. It's still somewhere in between 7 and 8, but much closer to 7. Well, then I'd look at this and go, well, it's closer to 7, so that means that 7.5 would be right in the middle, and 51 is obviously closer to 49. Therefore, I'm going to have a 7 point something, but obviously less than the 7.5. So that's going to squeeze right in there. So if I want to put these numbers in order from least to greatest, I have them now in order from least to greatest. And then one more, and this one just deals with some negative signs. So again, now remember with negatives, some people like to think of the bigger negative is actually smaller, but it's still the smaller number. So I look at this and go negative 5.5. That's the smallest of the three that I'm working with here that aren't in square root form. So I know those numbers are going to be in this order. Now, where do I put my other ones? I'm going to start on the far right with the negative 9, because the square root of 9 is 3. Put the negative in front of it, and now we have the negative 3. So I know that the square root of negative 9 would be the largest of those three that were down there. So now the largest of those 4. Now it's just a matter of figuring out the square root of negative 17.5. Well, again, I'm going to go perfect square to the left, or the smaller one would be 16. Perfect square bigger is 25, and I wrote them in the wrong order. I apologize. Since we're dealing with negatives, it would go this way. And then when I take that square root, this one's going to come out to be 5, so it would be somewhere between negative 5. This one's 4, so somewhere between negative 5 and negative 4 is going to be the square root of, or the negative square root of 17.5. Now, which is it closer to? It's definitely closer to the negative, or to the 16. Therefore, this negative square root of 17.5 is going to be closer to negative 4. Somewhere between negative 4 and negative 5. Well, if it's between negative 4 and negative 5, I don't have to do a lot of thinking here because I have a negative 4, I have a negative 5. It's in between there somewhere. We just had to put them in order from smallest to largest, least to greatest, and we have now done that. And that's going to conclude my lesson on estimating square roots.